Hi everybody, and welcome to the VodCast for Honors Biology at Desert Ridge High School. I'm Mr. Galladay, and today we're going to be talking about hypotheses, laws, and theories. So we're going to be reviewing a little bit of the language of science that we use a lot of times, and sometimes the scientific meanings of some of these terms are a little bit different than what we use in everyday language. So this is a good point to update your table of contents. Excuse me, to update your table of contents, and remember that you can always pause the vodcast to get caught up on your notes. Okay, here we go. First, we're going to review a couple of definitions of things that we've already talked about. First of all, of course, an observation is any time we directly perceive something in the environment, either using our senses or using an instrument. Now, this, of course, is different from an inference. And in an inference, we make some judgment or some evaluation using an observation, right? So, for example, you might see that someone is smiling. You might observe that they're laughing. You might observe that they're joking and things like that. And you could infer from that they're feeling happy, right? And it's important to understand that the observations are different than the inferences. A lot of times we make inferences directly, and that's because our brains are so good at making inferences. And so it's sort of a practice or a learned habit in scientific observations to be sure to keep your observations and your inferences separate from each other. Another closely related idea is that of evidence, right? Evidence is usually directly from observations. Observations and facts we typically use to mean the same thing. When we use evidence or we use observations to support a particular inference, then we say that that is evidence. Now, here's the thing that is sometimes comes into our language, our usage of some of these words, and that is the word proof. You probably know that proof in a mathematical sense is different than sometimes what we use in scientific terms. And the reason for that is because it's impossible to prove anything using observations. Let me give you some examples of this. It's not possible to make to prove something using observations. It's often possible to disprove something using an observation, but it's not typically possible to make a proof. And the reason for that, of course, we've all encountered someone who doesn't matter how much evidence you give them, doesn't matter what you say to them, they're just not going to accept the reality of the situation. It's often easier to disprove something, which is why we sometimes say that a good hypothesis needs to be falsifiable, right? This is why our evidence has to be reliable, has to be credible in order to be useful, because all we can do is acquire enough evidence to be believable, enough evidence to make our point. But you can always, somebody can always come along and insist that that's not enough evidence, no matter how much you collect. And so this is the basic difference between a mathematical proof and providing evidence. Okay, so we're going to look at these ideas of hypotheses, laws, and theories. And the first thing I'd like you to do is look at these. And the first one that we're going to look at is a hypothesis, and this is one that we've already talked about earlier in the year. And look at these four definitions and see if you can pick which one is the best definition of a hypothesis. Well, of course, the best definition is C. It's a testable statement. We usually say that a hypothesis has to be falsifiable to be useful. That is, that there is some observation that you could make that would show that is not correct. And we use this to build inferences and explanations, right? So here's our definition. We sometimes say that a hypothesis is a proposed explanation, right? Remember that it's not an educated guess, it's not a prediction. And some examples are here. The baby is crying because she is hungry, right? Now, this immediately proposes a possible prediction, right? If the baby's crying because she's hungry, well, then by giving her some food, she should stop crying, right? That would be our prediction that would follow from this hypothesis. Another, maybe a little bit more meaningful, is that sometimes inherited traits skip a generation because they're recessive. Okay? Again, this is an example of an explanation, and it immediately suggests a prediction that could be used to either to falsify that, and of course enough evidence we would say that it would prove that idea. Okay, the next one we're going to look at is a law. Okay, and this is one that we haven't yet talked about. So which of these do you think is a law? Well, it turns out that a law is a general description about how the physical world behaves, right? Laws, we say, are descriptive, and we're going to give several examples in just a minute. Laws are usually mathematical, right? But it's important to understand that laws describe, they don't explain. Laws are very different from theories. They're not a proven theory, right? Sometimes there's a misconception that theories eventually get proven and become laws, and in fact that is not how science works. Laws are not sort of the ultimate pinnacle of scientific knowledge. Laws are just merely descriptive. Now, they are very useful, but they are not nearly as powerful as a theory is. So, for example, Mendel's laws describe how traits are inherited, right? They're descriptive, but they don't explain anything. They don't by themselves explain anything. Mendel didn't understand how the traits were acquired, or how traits could be recessive or dominant. That came along later. And it's the theory that explains how the laws work. Okay, so given that, which of these do you think is the best definition of a theory? Well, hopefully you guessed letter D, and that is the definition. Notice that letter B was not involved in any of these, right? An idea about how something works that is unproven and lacks evidence, right? That's not any of these. All of these have some evidence or have some idea, some chance of being true. The closest that would come to this would be a hypothesis, but this is a much better, letter C is a much better definition of hypothesis than letter B, because this idea of a possible explanation. So a theory is a well-founded explanation. It incorporates laws, facts, inferences, tested hypotheses, observations, incorporates all of these into forming an explanation, right? Usually it's an explanation that unifies a whole lot of different ideas of science and from different fields of science, incorporates laws and incorporates observations. It's not an unproven law, right? Laws don't come from theories. If anything, it's the other way around. Theories often come from laws. The laws almost always come first, and then we later develop a theory that explains how the particular law works, right? Theories are not unproven ideas that lack evidence. So again, one example that we've already seen in class is Mendel's laws. Mendel's laws describe how traits are inherited, but it's chromosome theory that explains why that works. Okay, one important thing to keep in mind is that theories are always changing. As we acquire new knowledge, we are always modifying, slightly tweaking our theories as new knowledge comes about. Sometimes there are parts of theories that we don't fully understand, that new knowledge helps us to fill in those gaps, helps us to fill in those missing pieces of theories. Well, let's look at a couple of examples. Before we do that, I wanted to show you this little picture. So we have facts, which another word for fact, of course, is an observation that's been repeated. We have inferences that come from facts, we have laws, and we have tested hypotheses. All of these fit together, and when we can put all of these different types of ideas or these different types of knowledge, when they all interlock and make sense with each other, then we call that a theory. Okay, so here's some examples of some theories, and some of these will be familiar to you, some of them may not. If you've studied any physics, you may have heard of Newton's laws of gravitation. Newton's laws of gravitation, of course, were developed in the 1600s when Newton was alive, and he realized there was a relationship between mass, between two massive bodies, and their distance to each other. So it's a force that's exerted on each of the bodies, which is dependent on their mass and inversely proportional to their distance apart. Right? Well, Newton came up with this idea, but had no idea how it worked. Right? He knew that there was a relationship between these based on motion of planets. But we didn't have an explanation for that until Einstein came along almost 300 years later, right, and gave us a theory of gravitation. Now, Einstein's theory of gravitation involves sort of a bending of the space-time continuum, right? The way Einstein would explain this is that space and time bend around an object which is more massive. Now, of course, if Newton were to hear this, he would have no idea what you were talking about, because all he did was give us a law. It's a law that's very useful, but it doesn't explain how gravity works. And to this day, we don't really have Einstein's theory. The evidence for Einstein's theory is not all that great. And in fact, in recent days, we have an entirely different idea, which suggests that there are gravity particles called gravitons, and we don't really have enough data to show which one is correct, whether the graviton idea or whether Einstein's theory is correct. And it will be sometime in the future when we'll probably know this, but to date we still don't really know how gravity works or why gravity works. Okay, another example, of course we haven't talked about, and this is Boyle's gas law. Boyle's gas law states that the pressure, the volume, the temperature of gases are related. He developed this in the 1600s, but what we didn't have at that time was a model of molecules. We didn't have a molecular model. We didn't have a molecular theory, and it came down to a fellow named Bernoulli, almost 100 years later, and actually later, people even later in the 1800s, Dalton, as well as other chemists that developed a theory of molecules, a molecular theory that said that the reason Boyle's gas law works is because we have these particles, because gases are made up of particles that are moving around and have a certain kinetic energy. That explained how Boyle's gas laws worked, and again, the law came first. The theory which explained the law didn't happen until 100 or 200 years later. And of course, our theory is something that as we learn more about molecules, we learn more about things like the Higgs boson particle and so on, that really help us to understand this law even better. The theory is changing, but the law the law, of course, has been around and basically unchanged for several hundred years. Okay, to come around to the world of biology, of course, we've mentioned this example before. Mendel back in the 1800s came up with some laws of how a particular things are inherited, how traits are inherited. And it wasn't until other people came along with the idea of chromosomes that became a theory that explained how traits were inherited, right? It was this theory of inheritance based on chromosomes that explained Mendel's laws. Okay, so here's just a quick summary of these really three examples. In every one of these cases, the law came first, the theory came later. And in every example I can think of, that's the case. When we have a law that's incorporated into a theory, the laws typically come first, the theories come later. So theories are not, in fact, unproven laws. Okay, so again, theories are a tightly interconnected group of facts, inferences, laws, and tested hypotheses. Okay, so here are a couple examples for you to take a look at. I'd like you to, on the left side of your notebook, look at each of these and determine if this is more of a hypothesis, a prediction, a theory, a law, proof, or evidence, and be able to explain why. Okay, so take a look at each of these, write these on the left side of your notebook, and be able to say which of these this sentence would fall under, and be able to explain why. Okay, and I'll leave you with a little bit of a humorous note regarding science. And I hope in your coming day that you don't have any messy science to have to deal with. This is Mr. Galladay for Honors Biology at Desert Ridge High School, and I hope you have a great day.